There now seems to be two PS5 Hall Effect joystick kits on Amazon, both sold by GG's Own. Both $11 for two joystick modules, but that could include free shipping, so I don't think that's too bad of a price. The ones on the left look just like the ones I used in my previous Hall Effect PS5 replacement video and Hall Effect joystick revisited video, but looks can be deceiving. I'll put a link to those videos in the description. But the ones on the right look very much like the K-Silver joysticks I've seen pictures of, and the ones I've been trying to find. Even though 3 of the 4 reviews say they don't work, I had to give them a try. They have arrived and come in a small plastic box, so I at least expect the leads not to be bent up, and with some very tough tape holding it together, really packaged very nicely, and all of that packaging costs money. So now I have 2 what look to be very nice Hall Effect joystick modules. Nowhere in the description of the joysticks does it say anything about being K-Silver brand. As a matter of fact, the Amazon sales page lists them as NS Likey brand. But K-Silver is stamped right on the side of the joystick frame, so I think I have found what I was looking for. Of course, the first thing I want to do is test the joysticks and make sure they are working. Installing a defective joystick into a PS5 controller is just disheartening, and entails quite a bit of extra work. I have a power supply set to 1.8 volts to power the hall sensors. When looking at the plastic sensor housing with the 3 pins pointing down, ground is the left pin, 1.8 volts is the right pin, and the center pin is the output. Kinda tight pin spacing to get the grabber clips on, but if I don't jiggle the joystick too much, they'll stay on. This is the left-right axis I'm checking first, and the center voltage is close to 0.9 volts, so that's a good start. So I move the joystick to what would be the left when mounted in the controller, and the output voltage goes up to, I'll call it 1.8 volts. That's a problem. The voltage should drop to near 0 volts at the full left position. Looks like 3 of the 4 reviews of the joystick were correct. Move it to the right and it goes down to, let's say 0 volts. So the left-right axis of the joystick module is backwards. This would not work in a DualSense controller. And that really is a shame. I was looking forward to trying these. Now to check the up-down axis. Gets hooked up the same way, ground on the left pin, 1.8 volts on the right pin, and the meter gets connected to the center. Good center value for the up-down axis. What would be the up direction outputs near 0 volts, and what would be the down direction outputs near 1.8 volts. So this axis is correct. Of course, one axis does not make a usable joystick. Let me try the other joystick module. Might be just a defective joystick. Here I'm testing the left-right axis, and it's no good. Now the up-down axis, and it is correct. So both joysticks are the same. It's probably not a defective joystick. It's probably not the correct joystick for a DualSense controller. Let's take a look inside and see what I have here. The hall sensor cap snaps off by releasing 2 clips, one on each side. Then the magnet assembly. It just lifts right off the shaft, not really anything holding it on. Now on the orange Hall Effect joysticks, the magnet assembly was in 2 pieces. It's what allowed it to be mechanically centered. This magnet assembly is 1 piece. So there is no option to flip it over to change the direction of the magnet. So this is probably not an assembly error either. Now let me pull the good axis apart. Well now, a white magnet assembly and a blue magnet assembly. I'm now positive these are not made for the DualSense controller. These are made for the left-right axis to output a signal that is opposite of what the DualSense expects. And there doesn't seem to be any mechanical adjustment for the magnet position. That's disappointing all around. Here's a close-up of the hall sensor, one tiny chip mounted to what looks to be a double-sided PC board. 9303 printed on the chip, maybe 30 or 30 printed as well. A very nicely molded plastic piece. The molded recess has to be what holds the magnet assembly in place. The 2 holes in the cap to adjust the magnet position, but the magnet is aligned to the joystick shaft. Not sure how that's supposed to work. Maybe the mechanical adjustment part is inside the joystick frame? I'm pretty sure there will be a blue magnet assembly and a white magnet assembly in this other joystick. So I'm going to see if I can make myself one working joystick out of the two. I'm going to install both blue magnet assemblies onto the one joystick frame. Snap the Hall sensor caps back on. And give it a testing. Here's the left-right axis that was bad. Now when the joystick is moved to the left, the voltage goes down to near 0 volts, just like it should. And when moved to the right, it goes to 1.8 volts. I'll double check the up-down axis. Yep, it still works as it should. So this joystick should now work correctly in a DualSense controller. One of the buy two, get one that works kind of deals, I guess. But at last I have my hands on a K-Silver joystick. Before I install it in a DualSense controller, I want to see what kind of output response it has. I want to compare the output of these Hall effect sensors to the regular joystick potentiometers. So on my test board I have the new Hall effect joystick and the standard favor union potentiometer joystick. I'll use the favor union as the reference. I'll get it installed in my test jig and let's see how it does. Channel 1, the yellow trace, is the Hall effect joystick. Channel 2, the green trace, is the standard potentiometer joystick. The first test is simply installing a bar that mechanically connects both joysticks, so that when I move the bar, both joysticks are moved together. I'll set the scope up to capture a single trace, and then move the bar back and forth to generate a signal. Other than the noise, that looks quite good, and the noise is not coming from either joystick. The Hall signal is right with the potentiometer signal, and that is really what I want to see. A lot different than the previous orange Hall effect joystick I tested. Now I want to check the rise and fall times of the output, and the best way I've found is to let the joystick's internal spring do the work. Can see the fastest I can move my finger takes maybe 8 milliseconds, but the spring in the joystick can move it much faster. And the low to high here looks great. That looks less than a millisecond. Then I'll go in the other direction and get the high to low timing. Looks a bit slower, but still fantastic. Less than 2 milliseconds. And I would expect quite a bit of that time to be the mechanical travel time of the joystick itself. Slew rate on these sensors looks great. I don't think these Hall sensor joysticks are going to feel any different than the regular potentiometer joysticks, unlike the orange ones I tried last time. One more mechanical test, see if I can see how much output lag there is. I have the joysticks riding on a cam, and I'll turn the cam with a drill, first in one direction and then in the other. Unfortunately, the drill runs at different speeds for forward and reverse, but can get a general idea of the movement to output lag. I'll use the scope's cursor to measure the time difference between the potentiometer signal and the Hall sensor signal. So this measures about 3 milliseconds. From the waveform, it looks like the lag from high to low is a bit more than the lag from low to high, but really looks fantastic. I'm very pleased with that waveform. Now I'll reverse the drill. Doesn't run quite as fast. And I'll measure along the same line. Say about 3.2 milliseconds. I thought I had the joysticks lined up pretty good on the cam, but turned out they are lined up even better than I thought. The actual lag time from movement till the signal starts to change? Probably a little less than 3 milliseconds. That's outstanding. Last test. With such a fast output, how bad is the noise and jitter going to be? This is a measurement of the standard potentiometer output. Most of that noise is high frequency and is not actually coming from the potentiometer, but it is a baseline of the noise in the room from the computers, lights, and all the other electrical devices. Around 15 millivolts for the main noise band, and it's pretty smooth. Can see it go up when I get my hand close to it. Now I'll move the probe to the Hall sensor output. There is more noise there, but not that much more. Now there is some shifts in the, say, 1 to 5 millisecond range. I think that will be the jitter from the Hall sensor. But they are so small in amplitude, I don't think that they will be noticeable. Here with the sweep speed at 2 milliseconds a division, can see them a bit better. Maybe have an amplitude of 2 millivolts, 1/900th of the range. I really would be surprised if the AD converters for the joystick is more than 8 bits, so that 2 millivolts would barely show up as noise. There are a few noise spikes that could show up, if they are coming from the Hall sensor. Either way, I would say that is less noise and jitter than a worn potentiometer. I think it's time to put this in a controller and see how it works. This controller has a few years of use on it, bought when the PS5 was purchased. Now the left joystick potentiometer has been cleaned before, probably about a year ago, but can see the left-right jitter on the stick is horrible. It needs a new potentiometer, but it's going to get a new Hall effect joystick. Can't see, even with all the noise, that it's still pretty much reading on center. It just won't stay in the center. Circularity is still pretty good considering how much this controller has been used, and I'm sure the 10% is better than what the new joystick will yield. But that jitter has to be taken care of. It does cause some problems when playing. Since both axes of this joystick still read on center, I thought I would get a center voltage reading, give me some idea how far off the original joystick potentiometers are. I'm soldering 3 wires to the controller, one on the joystick ground pin, and one each on the potentiometer center output pins. I'll start with the left-right axis. Can see with these values how the joystick mounted in the controller reduces its movement range. Out of the controller, the values would go from just about 0 to 1.8 volts. See if I can move it and get the gamepad tester showing a good center position. Okay, that is very close. So the left-right potentiometer is pretty close to center, reading about 20 to 25 millivolts off from the perfect electrical center position. Now the up-down axis, that looks right close to center. The long meter leads may be introducing a bit of noise into the signal. Now that is off a bit there, 50 to 60 millivolts. Now if this potentiometer were to be replaced with one that was, say, this far off in the opposite direction, it would not turn out well. Might even be off enough to drift. So I'm going to try and see if the plastic deforms enough to adjust the new Hall effect joystick. I have the 1.8 volts supplied to the joystick's left-right sensor, and getting about 880 millivolts, so about 40 millivolts lower than the one that is coming out of the controller. So installed in the controller like this, it would show that the joystick is off to the left a small amount. Oops, wrong way. But it did seem to alter it. So I'll move the joystick full to the right and then stick a small metal object into the right hole on the sensor, and then push the joystick back to the left. Not applying a lot of pressure here, I don't want to break the plastic shaft. That does look to have deformed the shaft. I'll move it around a bit because I would expect it to try and recover its shape. This could be a very slow process. Yes, it is slowly returning to its original position. Probably won't quite get back to it if I applied enough pressure to the plastic shaft. I'll just repeat this till I get it where I want it. I'm stopping here at this. 913 millivolts is plenty close enough, and it seems to be staying, so I guess the plastic shafts can be deformed enough to move the center position. Now the up and down needs to move quite a bit. Also, the up and down axis has a lot more spring and hysteresis to it, so going to make it even more aggravating. But it's the same process, just slower. I really don't like how these have to be centered. Don't like it at all. I'll get the old joystick out. And it's an Alps joystick. And then install the new Hall effect joystick. I'll solder 2 of the frame pins in and then make sure the joystick is flush with the PC board before I solder all the rest of the pins. Before it goes back into the case, I'll hook up the battery and connect it to the computer with the gamepad tester running. Left-right axis is very good, as long as it stays that way. Up-down is still reading a bit low. I think I'll try and overcorrect the up-down axis. I would expect over a few days it to give up a bit of its deformation. So I stopped here at this. Can see the up-down axis is just a bit on the downside, and it seems to be staying there. I'll see in a few days if it's still there. I'll put the controller back together and try it out. Now that the controller is back together, I'll try out the circularity. can see it's not great. And I would bet that the circularity was made worse by the deformation of the shafts to try and center it. Much more circularity error for the up-down than the left-right. Now the right stick is very good, better than it was. I probably have the controller mainboard in a little better position than it was. There is a bit of positioning of the mainboard in these controllers, but after using it some, the mainboard is probably going to move to the position it rests in, and that is where it will stay. So, all in all, circularity is bad, really like it is with most replacement joysticks. All are potentiometer based. Centering is very slow and tedious, and I do question if it will even stay centered. The plastic shafts might move back a bit over time, but probably will stay very close to the center. Only time will tell with that. I don't see any jitter showing up in the Hall joystick, so that is great. And just using the gamepad tester, it feels like a regular potentiometer-based joystick. Definitely not the smooth feel of the orange Hall joystick I tried last time. Having to buy 2 joysticks to get one usable one, not great. Doubles the price of the joystick, making it a bit pricey. But if you want a Hall sensor joystick that, best I can tell, feels like a regular potentiometer joystick, this may be the answer. So we know that the blue magnet holder and the white magnet holder have the magnets mounted in opposite directions. So I wondered, would it be possible to turn the magnet around and end up with both joysticks usable? The magnet is in a plastic pocket, and it looks to be held in place with a bit of melted plastic on the ends. I will mark it so I know which way it needs to be turned. I will use a knife to cut away a bit of the plastic melt. And then use the knife as a pry bar to lift the magnet out. That wasn't too bad to remove. Getting it back in place is a bit tedious. I still have some of the melted plastic on the ends, so I'll completely remove it from one end. First, I'll insert the magnet into the end with the bit of melted plastic lip, and then just press it into place. I will make sure that the magnet is fully seated into the plastic pocket. And then I'll use a soldering iron with the temperature set to a little over 500 degrees Fahrenheit to melt a bit of the plastic. This is a tip I use just for plastic. Don't use your regular tip you use for soldering, really makes it hard to clean. Needs to be pretty flush, don't want it hooking on the Hall sensor chip. I overdid that end, melted it too much. I'll see how bad the centering is to see if this is even worth it. Snap back on the Hall sensor cap, and now to test it. Well, the centering is not bad. It's not quite as good as it was with the blue magnet holder on this axis. It would work. Quite a bit of work to rotate the magnets, but would make this joystick usable in a DualSense. But I will never know for sure about this one because it's getting torn apart to see if there's any mechanical slippage inside the joystick that allows it to be adjusted. I'll save the magnet holder pieces and the Hall sensors. I might end up ordering another set. The joystick is held together with 4 metal tabs bent over, just like every other one I've pulled apart. It looks closer to the Alps design than the Favor Union. Matter of fact, it seems very similar to the Alps joysticks. A bit of grease on the base plate. Again, shape is a lot like the Alps. Spring is a bit weak. In my memory, the Alps spring was a bit stronger, but my memory may not be correct. The plastic insert is quite a bit different than the Alps. These don't click when moved, so I would expect that plastic insert to be the reason. As I expected, the plastic arms are all one piece. The up-down axis is the slotted outside arm, and this is the left-right axis. So the only way the centering adjustment will do anything is by deforming the plastic pieces. That is really disappointing. On the positive side, this thing looks so much like an Alps joystick. The arm ends and even the frame punch-outs look like the Alps. So it might be possible to just install the magnet holders and hall sensor caps on an Alps joystick frame. I'll have to look into that. After using the controller some, actually playing some games with it, to me it feels like a regular potentiometer joystick. Definitely not the smooth feel of the orange hall sensor joystick. I really kind of miss that smooth feel. But I'm going to continue to use this one, at least for a while, just to see how well it holds up. One other thing I did notice, this joystick feels easier to move than either the Alps or the Favor Union standard joysticks. I do believe the spring tension on it is a bit weaker. It's slight, but I can notice it. But I guess that would mean less wear and tear on one's thumb. Having to put together a usable joystick from the two in the kit is a big problem. It is a bit of work to rotate the magnets to get two usable joysticks, but it can be done. Just be aware that you will have to make modifications to the joysticks to use these in a DualSense controller. Thank you for watching.